So we did our distance here. Let me see that. I said false. So it appears as I would say, I'm just going to say false. So now let's do our distance for 30 points. Okay. I don't have a calculator for this. We're just going to have to go ahead and insert 3 of these. I will do the normal distribution for at least 2, and then we'll move right on from there. So let's go ahead and get our data. Let's analyze our data. Data analysis. If you guys remember, we're going to use the descriptive statistics because it's going to generate the mean, the standard deviation for us very quickly. Let's choose the appropriate one. And we're going to choose our A column. And we have labels in the first row. And then we want to choose our C as far as our output goes. And summary statistics, confidence level. Let's just go ahead and say OK. So we have this. I'm just going to go ahead and take this. I want to wrap this text. I want to merge and center it. And I want to change the color back to this yellow. All right. And go ahead and open this up. I am going to go ahead and also run those lines. So now we need the normal distribution of the wire twist angle at 20 centimeters with a voltage of 6.155 kV. Now notice that I did not put my uncertainties in the last one. If I wasn't trying to get through this video, I probably would. Norm dist, select this value, and we know what our mean is. It's here, of course, F4, comma, and then we need our standard deviation, F4, comma, false. Close that. This is most likely some scientific thing. So we have all of our information here. All right, I can select both A and B, and I can insert this column, this chart. So let's go ahead and put our axis titles on here. It's our average wire twist angle, degrees, DEG. Okay. And then we have the, what is this going to be? This is the normal probability. Probability distribution. Okay. So I would like to put that in here too. And I'm just going to add to this at 6 volts correlated to the average wire twist angle. All right. So of course we're going to switch this out. Going to change our axis options just like we've done before. And this is going to be for B. And so we have ourselves a nice normal distribution. All right. I do want to do that one more time. And this time I'm going to magnify the screen a little bit. So just in case you guys couldn't see what I was doing. I'm going to go ahead and enter, insert, insert, insert. I'll do the same for all of these. So that is green. I think that's this green. Okay. So I'm just gonna, just for the sake of repeating this with a certain level of magnification, I'm gonna go ahead and select my data analysis, descriptive statistics. We want to select this wire twist angle data at 14, and then we want to output this right here. I'll say okay. And I want to go ahead and change this color back to blue. I'm going to go ahead and wrap and merge and center these. Okay. And we want to take these values and let's go ahead and cage them up there. So we have this, let's just run this normal distribution. Say normal probability distribution, wire twist angle at 14 centimeters with I'm just going to say at 14 centimeters because all of them are going to have the same voltage. So this is equal to norm dist (78). Then we need the mean of that. F4, comma, standard deviation, F4, comma, true. So this should stop, and it did not. All righty. I could probably put this in scientific as well. All right. So we could take these two and see if we're going to generate our normal distribution. Okay, I think I've chosen the wrong thing. Let's see. It should be false. All right, there we go. So you guys make sure you label it. Okay. Oh, degrees. And then we have our normal probability distribution. All right. Should not be any kind of correlation. It's the average wire twist angle. Is this right? I didn't need all of this. All right, just take a little bit off there. And let me go ahead and bring this up. We want to move this to 60, 65. All right, there we have our next one here. Our next chart showing some significance statistically. All right, so from here, instead of doing the normal distributions, again, I am just going to take or find the data because ultimately we're trying to show that Coulomb's law actually works. And now I'm going to duplicate. Remember, I want to use this and I'm going to duplicate this. I want to move it to the end and let's see how our comparison goes. And so we have our distance. I'm going to say 30 analysis. Okay. Please use some other type of terminology. So our expected value should remain the same. We have our distances, they should remain the same. And now the only thing that really is going to change is our average wire distance. So let's see. I'm going to go to 30 and I'm thinking about this, right? This is the angle, 20. Oh, go back. Oh, yeah. So the average angle wire twist at 20 is this one. And then it says 55 at 76. This one, it's going to be at 10 or 23. And then at 9, we have 123. And then at 8, this is 8, that's 7, this is 8. Okay, 7, 6, 5, 6. I think it's the last one. Oh no, I don't have a 5 or 6 for this one. So I can just remove these. I can remove all of this. Clear. Here. All right, so we didn't have to change this. This is our spring constant. We're keeping it with the slope intercept at 0. And then we have our electric force. This we're keeping. And then we have our Linus here. And this is our measured value. Let's see, we're trying to compare our expected to our measured. And we end up with a negative 2.02. That's better than what we were getting for 5 points.